Hello there. My name is Michael Sutton, and I'm the instrument sales specialist for Eppendorf, supporting our automation pipeline. Thank you for joining us today. In the day of COVID, we are all accepting the new normal, and I'm really excited to be putting together this recording for you and look forward to the question and answering sessions afterwards. So with that, we'll dive right into our agenda. Today, we're going to talk a little bit about who Eppendorf is, why one would want to automate. We'll take a little bit of a deep dive into the EP motion, and then we'll take a look at our application support and beyond, specifically to the NGS workflow as it pertains. And with that, we'll dive right in. So Eppendorf is a privately owned company that was founded in 1945. And believe it or not, we are still owned by the original two families. That's really special because that means that we can really focus on the customer experience and making sure that the work being done in the lab is fully supported from all. Now, we're a large company with over 20 direct marketing and sales organizations that accounts for quite a few number of employees. Now, two items put Eppendorf on the map, the first of which was in 1960 with the piston stroke pipette. Quickly to follow was a tube that many of you will probably recognize, the Eppendorf tube, 1963. Together, this puts together a microliter system that enabled a lot of complex workflows in the lab that previously were either unsafe or were not as accurate as it could have been. Now, accuracy and precision is something that we're going to be talking about a lot today, and it's good to know that this same theory was existing back in the early 60s as it does today. Now, beyond the invention of those two key milestones, Eppendorf continued to drive forward with the innovation train. And specifically, we're going to be talking about the innovation that was released in 2003 with our liquid handling workstations, the EP motion. These were the first step towards automating and bringing all of that innovation from the first piston stroke pipette and microtube into a fully enclosed workstation to automate that workflow. Now, again, we are a global organization, and I point this out to show the reach of not only Eppendorf, but our customers. And that innovation does funnel up through the organization, and we try to pour it back into our products by both listening to the customers and responding to the needs of those customers. Now, we're going to be talking about automation today, which is in the middle of the very top row there, but I cannot say it more that Eppendorf does support the lab from end to end. Be it manual pipettes or -80 freezers, there is most likely a solution where we can help tie everything together under the Eppendorf umbrella. Now, for the moment we've been waiting for, we'll dive right into the advantages of automation with the EP motion specifically. Now, to set this up, I'd like to say that we polled a number of end users and key opinion leaders and put together a list of why folks would automate. Now, with that, we'll start with the first one, the obvious one, error-free workflow. By taking the pipette user out of the equation, we take a majority of the error out of the equation. By using piston stroke pipetting, we are taking advantage of the machine accuracy that a human could not achieve on their own. Coupling that with an infrared sensor that can measure liquids quite better than a human eye can, in a full enclosure, we've created what we like to believe a human pipette user-free, error-free environment. Now, it's important to keep in mind with sample tracking. We're taking the human out. How are we going to track all this? Well, this system is tracking the samples through the entire workflow, and here are some key things that are always documented, making a real audit-friendly environment. So not only are we putting an error-free environment, but we're backing it up with the documentation to support a clinical or a highly regulated environment, I should say. Now, versatility is a big one. Now, with the EP motion, we are workflow agnostic. And what that means is on the same platform that we're doing nucleic acid purification, we can also do PCR or next generation sequencing library prep. Because the system is open and flexible to the workflow, you're able to flex to the needs of the demand of that day. And that versatility is very high on the list of things that automation kind of supports. Now, flexibility of throughput is an obvious one as we develop methods in the 8 to 16 sample range, and then we expand that to the 96 to the 384 well throughput. It allows a stepping stone process so you can fully embed that workflow in whatever context makes sense for that day, be it a small batch or a high batch. And that flexibility is largely due to the software and its ability to flex with your need. Now, accuracy and precision is a big one for all users, not just that of automation, and it will come up again. But what I will point out here is the accuracy of the EP motion at 0.2 microliters. That's 200 nanoliters. That's 1.76% CV, which is inhumanly accurate, as it should be. Now, I mentioned inhumanly accurate. Another thing that the robot will not do that humans tend to is show up groggy or get tired around 2:30. Productivity is a big thing with automation. Once everything is in play, your productivity is now something that can be measured, and there aren't the human error element, or human element, I should say, to get involved there. Now, contamination prevention, I'll call out the first three of those squares there: the UV sterilization, HEPA filter, and enclosure. Now, this is just three of many ways that the EP motion is preventing contamination, and it's a big deal when we're taking a watchful eye out of the equation. Contamination needs to be paramount. And user intuitive interface. Jumping right into, this is what the EP motion software looks like. As you can see, it is designed to be very user intuitive. We're dragging and dropping commands onto a procedure line and interacting with a work table as I read those headers from left to right. And we'll go a little bit more in detail there later in the presentation. With that, I will introduce you to the EP motion. The EP motion itself, the software is the same amongst all three platforms, but it does come in three tiers: the small, medium, and large sizes, if you were. We'll start with the smaller version, the EP motion 5070. This is a 4-deck position system that's ideal for basic applications such as PCR prep. In the NGS space, normalizations, dilutions, and pooling are very capable. I will call out that this is for the 96 well variant. If we are in a 384 well variant, we would probably go with a larger platform. And with that, we'll segue right into the EP Motion 5073. This system can do all the applications that the 5070 can do, but then we start to integrate more complex functions because we have more deck space and more available real estate to increase the complexity of the workflow. Two that I want to call out specifically here are a full NGS workflow involving bead chemistry or enzymatic chemistry. Either way, we can also accommodate bead purification. This is using some of the advanced features that the 5073 is enabled. And with that, we roll right into our 5075. Again, it can do everything the previous two can, but now we're dealing with a platform that is nearly 2.5 times the size of the predecessor, and easily our most popular platform in the NGS community. With this system, we're working with NGS library prep at 96 and 384 well scales, nucleic acid purification, plate-based chemistries, you rearrange plates to 384 well plates. This is really where the creativity of the end user and the programmer come into play. Because the footprint is so large, the deck spaces and available resources on deck allow for much richer complex workflows. So I just said a lot, but some things I want to highlight here, and I've literally highlighted them for you, is the bullet number 3 there: contact-free liquid detection and work table scanning. This is something that is accommodated with the infrared sensor, the eye I pointed out earlier. This is huge for mitigating any errors that the human may have inputted when loading reagents and the like. I'll also call out the pipetting range from 200 nanoliters up to a full microliter or full milliliter, all with an average less than 1% CV, with the 200 nanoliter being the exception. It's a vast pipetting range that should accommodate any and all NGS chemistries, including your wash steps. And that's good, and the actual automatic tool selection on board will prevent you from having to really worry about that too much. Again, last but not least, the intuitive program on the fly software. This is really what's going to keep the system up and running, and I always like to say a system will be used as easy as it is to program, and I think the EP Motion really shines there. So with that, I'll give you a quick example of this. This is the command line, the procedure line, and the work table going from left to right. As you can see here, I've dragged 3 commands over. The first command was commanding or programming the number of samples. I've identified that number of samples as 24. Coming in with a reagent transfer, and that will be a reagent transfer of 42 microliters, followed by a sample transfer of 8 microliters. As you can see here, by manipulating the very basic inputs of volume and destination and source, we're able to program a basic PCR reaction in 3 very simple stages. All right, getting a little more into the hardware of the instrument, the EP Motion has liquid classes and on-deck incubations. I want to call these out specifically because they are in many cases the most important aspects of the ingest workflow. Starting at the top, you can see that the liquid class glycerol is selected. This is a liquid class that we would use for any bead chemistries or anything with hyperviscosity. This is important because when we're pipetting water, we treat it very differently than we would pipette glycerol. The EP Motion and automation is no different. It needs to be able to treat the liquid the same way a human would, and we program that finesse in just as such. In terms of incubations, we have stable incubations with our thermal module, as well as shaking incubations with our thermo mixer. And you can see those temperature ranges on average 0 to 110 degrees Celsius. So it can accommodate many of your biological temperatures, as well as your mid to low range incubations. If vacuum technology is required for any solid phase extraction or filter plate work, the EP Motion has a module to accommodate that. Again, the system is as flexible as the workflow is demanding of it, and this would be an example of that, adding a module to accommodate some filter-based extraction workflows. Now, per site tip height configuration, I call this out specifically for folks working with bead chemistries, as well as organics and non-organics. We can finely tune where the tip is going to be pipetting from at all aspects of the workflow. This will make sure that we're not going to be disturbing any pellets, beads, rings, layers, anything like that. And this is all relative to the meniscus or the bottom of the tube, which is very fine-tunedly measured by the infrared sensor mentioned before. For any bead-based work, this is the magnet that the EP Motion uses. As you can see on the right from this, this motion captured image, we are collecting the beads just as such. As you can see there, there's plenty of room at the bottom of the well for your elutions, washes, full dries, and it's quite a powerful magnet. For normalizing, pooling, cherry picking, and rearraying, we have full CVS integration. This is going to CSV integration. This is going to allow you to outline everything on your PC and upload this, speeding up the programming process significantly. One last shout out to our accuracy specs. As you can see here, the accuracy is on average less than 1%, with the one exception being at that lower tolerances of the 50 microliter and the 10 microliter tool. Again, inhumanly accurate as it should be on an automated platform. Now, last but not least, we've got a few slides here. I do want to call out that the EP Motion is very open platform. We are kit agnostic as well. So we have supported workflows from the likes of all your manufacturers. Here's a short sampling of them. We work directly with these folks and their application scientist teams, as well as their automation teams, to make sure we're putting forth a complete qualified solution for you. And with that is a quick sampling of some plates. You'll recognize some of the usual suspects in the NGS arena, but be it whole genome sequencing or RNA, in this specific case, single cell RNA, we're able to support the chemistries that are used and automate that, and again, give you all those benefits of automating while supporting you with the chemistry and the application support of the manufacturers. On top of working with kit manufacturers applications team, Eppendorf has our own application support team. Here is the email in which they love to be reached out at, bioapps@eppendorf.com. This is a free resource to all EP Motion users And what it gives you is access to troubleshooting, project planning, workflow consulting, and labware support. Those 4 bullets are a lot more powerful than they seem, and having that at the tip of your hands is a great resource. So I like to call out some of our existing users. Some of these are names you'll recognize. Others are government entities, especially now more than ever in the time of COVID-19 pandemic. The EP Motion is a trusted platform, not only with the CDC and others, but major players in the research community. So with that, ultimately Eppendorf is here to try to provide the Eppendorf solution, which is ultimately your success. Working in the NGS field myself for 3+ years, I've learned a lot. And one thing that I think is translatable across all is data speaks more than anything. And when we take error out of the equation, we tend to increase throughput, which ultimately increases data. And data answers questions, data solves solutions, and data leads to success. So with that, I will end the PowerPoint, and I look forward to the question and answering session at a later date. And I appreciate you for tuning in as long as you did. Take care. Bye.